All right, I decided to do 3 videos. Here's video 2. I'm going to show you where the double angle formulas are derived from, and discuss a little bit more about the double angle. You remember the sum and difference, but if we look at just the sum formulas for sine, cosine, tangent, okay? Well, where does sine of 2 alpha come from? Well, if I replace beta with alpha, I now have sine of alpha plus alpha, sine of 2 alpha. Well, I have sine alpha cosine alpha plus sine alpha cosine alpha. I have the same thing, so I have 2. And as you can see over here, that's the formula for sine 2 alpha. So likewise with cosine, well, if everything's alpha, then I got cosine squared minus sine squared. Now you notice I wrote 3 and they're underlined here. Cosine squared minus sine squared. I used to dodge that one when I first taught trig, 30 years ago. I used one of these two. I thought, oh, it's easier. But I noticed the students had a harder time in cleaning those up. You shouldn't, but people kept messing up, multiplying by 2 by a fraction. When you multiply 2 by a fraction, you only multiply the top number, but people would multiply the top and the bottom. So I'm like, all right, this one's probably the easiest. And this is the one we actually use in calculus the most. So these two are used in calc a lot. So double angle for those two. I don't want you to get you scared like all these are going to be used. We will use a different version of the half angles for calc, mainly for BC calc. So these are super important to us in calc, but other than that, we don't use the sum and difference and too often. Okay. All right, cosine. Now, how do we get these other two? We can substitute. If you remember, there's an identity. Sine squared plus cosine squared is 1. If I solve it for sine squared, I get 1 minus cosine squared. And if I put in 1 minus cosine squared here and clean it up, that's where the 2 cosine squared minus 1 comes from. If I solve that for cosine squared, and I get 1 minus sine squared and put it here, I'll get 1 minus sine squared, which is 1 minus 2 sine squared. So those are just 2 other looks. If you're going to memorize them, just memorize the first one. That'll do good for you. But anyone can use whatever you feel like when you plug it in. Okay, I'm going to be mainly using this guy. And then the tangent. Let's show you that one. This was alpha. And you got tangent alpha. So now these are like terms. So I have 2 tan alpha. And I have tangent alpha times tangent alpha, which is tangent squared. And so there's where that formula comes from. Okay? So I want to kind of do a little video of deriving this. But something I didn't mention on part 1 video is, do you remember how we did cosine of 15 and sine of 22.5 using half angles? I didn't do any double angle. We don't use double angles to find these values only because we can already find all the multiples of 30 and so forth. So for example, like the sine. And also, it doesn't have to be alpha. I mean, it could be beta, it could be theta, it could be some Greek letter. It could be triangle. Sine of 2 triangle is 2 sine triangle, cosine triangle. It doesn't matter. All right, so we don't use this to find it. So if I were to try to find sine of 60, well, I already know sine of 60, but it's 2 times sine of 30 cosine of 30. And you guys, why did I go to 30? Because remember, this is the double angle, and this is the single angle. So this is twice as much as this. So if this was 60, and 60 is 2 alpha, alpha must be 30. So that cancels, and I get sine of 60 is rack 2, which I already know. Okay, so we really don't use double angles to find anything. I just wanted to show you one. And that's about all we can do, okay? All right, my next video I will show you when you're given some information how to solve these.